main thing is, hey, we just turned this thing on. It hasn't been used in over a year. It's been moved from building 1 all the way over here. So you're not sure if all the components working right, or the last time they had a calibration. So one thing I'll show is I'll do one of the calibrations. So just kind of a quick little interface. You got these buttons at the top here. So basically everything you can do from this control panel, you can also do
on that screen.
Yeah,
right?
on the screen. So for instance, if I want to go ahead and close the furnace, basically it's this button here, and then it's going to say, hey, furnace, close, apply. And then, so everything you can do here, like I said, you can do from this user interface. So let's say we go to this control tab, and you want to go to the furnace, and then we want to open it.
Gotcha.
So
Okay.
pretty much you can do anything from here, or anything, whatever is easier. Sometimes I like to switch it up, just make sure everything's working right.
Yeah.
So there's a bunch of different things in here. You got the float/lock of this little piece right here. Basically, I'll show it to you a little bit later, but essentially right now you see how it's freely moving. If you want to lock it when you're putting in, I don't know, a piece of material that you want to test, you basically hit this button here and it says float, and you want to lock it down if you want to go ahead and torque down these screws to secure whatever material you're looking at. Apply, and then you do that, and then you notice it's not moving anymore. But if you want to basically make it float again, you just kind of hit the apply again, and then it will go ahead and loosen it. For time's sake, we have experimental tab here, which is if you're running an actual experiment, you're going to be mainly into this tab, and in here you have basically like a summary that shows, hey, this is the type of test we want to run, this is our sample name, this is the sample dimensions, and then you can go even further in depth and then make your own procedure. For instance, if you want to go ahead and ramp 3 degrees C per minute up to 60 degrees C, 100 degrees C, 500 degrees C, whatever temperature you want, and then you can do that, and as the temperature is ramping, you can ask the DMA to take certain tests, like for instance, if you want to do a temperature ramp and then do a frequency sweep and allow you to kind of get the mechanical properties of whatever material as you ramp up, for instance, glass transition temperature, if you want to characterize a material or resin or even a thin film. But just before we can do any of that, like I said, hasn't been ran in over a year, so let's just go ahead and do one of the calibrations. So let's do clamp, and we have all these different pieces of these different clamps right here. This one is the dual cantilever, but in all these little boxes we all have, so right here we have like different standards. This looks like it's another one of the clamps. Some of these actually aren't applicable to this piece of equipment, some of these go to the DSC, but for instance this looks like it's the thin film clamp. I won't be showing too much of that today, but essentially instead of using something rigid like these pieces of metal here, if you just use a thin film, it will kind of like stretch it. And there's a bunch of other clamps you can have on here, but for instance, let's just go ahead and run this one right here. So just to go back one, that's on the calibrate tab, clamp, and then you can choose all these different clamps. You have single cantilever, 3-point bending, we have tension fiber, compression. I'm not sure if we have all these pieces of equipment. Right. I know we have the dual cantilever, which is currently installed right now. So we're going to select that, and then we want to do calibration type. We want to do all calibrations, so that's going to include the clamp mass calibration. So basically what I'm going to do is I'm going to start it up, and there's nothing going to be connected onto it because it needs to calibrate the mass of this clamp right here. So let's go ahead and get that started. So press next to begin the following clamp calibrations. So next, let's see, close the furnace. So we can go ahead and go to this control tab, and then go to furnace and hit close. So now that the furnace is closed, we can go ahead and start the calibration. So this could take a couple minutes. Part of the calibration is complete, basically the mass calibration of this center clamp right here. So we can move on to the next step. So step completed successfully, press next to open the next calibration window, next. So then it wants us to use one of the calibration standards. And that guy is this one right here. There's a bunch of other ones, but this is for the dual cantilever. And what you'll need is a micrometer. So this one's actually mine.
Oh, we have a few other.
But I mean, it's basically just measuring dimensions.
Yeah.
So this cantilever right here is actually the length, because there's a bunch of different other cantilevers. This one is the 35 millimeter one. So the length that you're going to put into here is the 35, and it kind of defaults to that because it knows you're using it. However, the things that could vary are the different thicknesses of these standards. So for instance, we're going to use this one right here. So for the width of this guy, let's measure, it's looking like 12.76. And then thickness looks like 3.18. So now that you put these, you have these dimensions, you're going to want to install it. So there's a couple of tools that will be included with this. So first thing what I want to do is when you're installing material or standards, you want to make sure that this is on float so that you can kind of easily move it, because if it's down here stuck,
yeah,
you can't.
If it's locked, right.
Yeah. And then you basically want to put the standard between these bars and move it all the way across. Just kind of like that. And then now that it's in position, you can go ahead and torque down the screws. So that's one thing that you'll need. You'll need a torque screwdriver.
Yeah.
And I think they recommend between 8 to 10 inch-pounds. So I just set for 9. Which is right in the middle. So now that this is in place, you can go ahead and torque down the screws.
And it's the 3 screws, right, that you clamp down on each?
Yeah, it's this one and that one. Hold on, but this one is looking kind of off. Yeah, that little nut was a little loose. I'll try that again. Okay. There we go.
So you want to do the middle one last, typically?
Yeah, at least that's what I usually do.
Just to get an even kind of clamp on it, probably.
Yeah. I want to try to make sure it's as... seems off a little bit. I just want to try to make sure it's as straight as possible. I mean, it's not going to be perfect. Oh, actually, I think what will make this easier is, so now that you actually have your piece of material in there, I forgot to lock the float. So now you lock it, and this isn't moving, so it's going to be a lot easier to tighten down. Yeah, and like I mentioned, I think they recommend 8 to 10 inch-pounds. So this one's just set at 9. So, got your standard all fastened. You have all the dimensions that you measured with your micrometer. You put them in here. Let's see. that, mount the sample, close the furnace. So now let's just close the furnace, and like I showed you before, you can use either the software on the computer or the actual instrument itself. Over here, close. So now that the furnace is closed, we can go ahead and press the calibrate to begin the calibration. And this could take, it doesn't say. So this could take a couple minutes, just like the previous step. So the furnace opened back up again, and it says step completed, press next to view calibration report. So we're hit next. Let's see. Okay, so this is what you want to look for right here. You want to look at the compliance, and you want the compliance to be less than what the typical value is. So this is reading 0.159, and the typical is 0.2. So calibration passed, we're good to go. Here, but you know, we just did that one clamp calibration, so the dual cantilever, the compliance came back, it's good to go. We're well within the range that we're supposed to be for that size of standard and for this dual cantilever clamp. So go back, cancel, but as you can see, in order to run the instrument, there's position calibration, there's electronics, force dynamic calibrations that you can be doing. I won't really go too much into that. A lot of that information you can just kind of look up videos online to find it. So this is basically, in here you can make the different procedures that you want to perform. You know, let's say you want to see how a material reacts to increasing temperature, and you're applying, I guess, suppose this little metal bar, the standard here, let's say it's like a 3D printed resin, and it's some experimental resin that you made combining different materials, and you want to just quantitatively compare one to the other. Let's say you want to look at the glass transition temperature. So in that case, as you ramp up the temperature, basically it's going to be moving this center, what should I call it, the center clamp cylinder, kind of slowly up and down, moving it, and it's basically holding it here, but this little center part that's actually going to be kind of oscillating up and down. And you can kind of change the frequency at which it does that. You can change the temperature, you can change the rate, and then essentially what it's going to do is it's going to give you all these different curves to kind of allow you to calculate at what point does this material become basically rigid, and then kind of turn it to rubber.
Gotcha.
So basically, at least for 3D printed resins, I mean, that was one thing we were looking at. It's like, hey, you know, at what point does it become this rigid, brittle material to this kind of rubbery as you increase heat and as you keep
just want to see what work environment is.
Yeah, and it allows you to see, like if you run the same exact test on 3 different resins, and you want to see, okay, well, resin A has a glass transition temperature here, resin B has a glass transition temperature here, just kind of allows you to show, hey, all right, based on this data, we should go with this material because it's going to be under these sort of conditions. Right. Gotcha. Something like that.
I got you. Okay.
That's just like one small example. I mean, that's the only thing I've really used it for here. I mean, there are tons of other procedures and experiments you can do on here. Like I mentioned, some of the other clamps actually, instead of basically perpendicular like it is here, it's basically going to turn it vertical, and it's going to kind of like stretch. Like if you have a thin film, it's going to kind of stretch this way.
The less acid.
Yeah, so there's tons of different things you can do. But for instance, for this, if you want to go ahead and specify the procedure, a temperature ramp, and basically notes material is heated at a constant rate while heating, the material is deformed at constant amplitude over a range of frequencies. So you can kind of change all that. And as it's oscillating up and down, as it's heating, you can kind of track the mechanical properties of that material. So there's a lot of different things you can do. In terms of the procedure, you can change the temperature, the final temperature. Let's say you start at 35 C and you want to ramp up to 60 C at a rate of 3 degrees C per minute. And then if you want to hold at that final temperature for some amount of time. So there's a bunch of different